Okay, hi. Okay, we're going to do problem one, which is to write an efficient program to find the sum of a contiguous subarray with a one-dimensional array of numbers that has the largest sum. So making sure I understand the program, in layman's terms, you want to find the largest total in a connected snippet of the array full of number values, and the total sum is just one number. This is the array that I just came up with myself as an example. So in an array of simple negative and positive numbers, we want the largest total sum of a section that's like fully connected. Let me see if I could demonstrate so this would be contiguous, whereas this and this would not be contiguous. So yeah, and okay. Um, So obviously we have to see where is wise to like start and stop. But how can we figure out with so many possibilities, which one's the best place that will yield the best total? So naturally we humans have to iterate through every possibility that comes to mind, which is kind of the brute force method. But that's going to take a very long time. I think it's going to be like it's going to end up as quadratic and cube time because there would be uh, two loops and then one last loop to compare when iterating through. So um, these two would be when I was going through and just doing a brute force thing. I did this and then it would be like -2 and then I would add this together, -2, it would be -1, and then I immediately realized I was like, well, I'm using this number to and then this number. I'm not adding everything up together, and that went from cube time to quadratic time because we were able to shave off one loop. Because we have this and this, which is all we need. So the correct answer for all this is going to be the same as these two. Um, so that's going to be -5. And then I just use -5 with 5, and that's 0. And then I just take 1, and then I take -1. So we're back at -1, and then, yeah. So that's how I did it. And I also realized it's good to do it the brute force way because you realize all what's unnecessary and what's repetitive in your work. And if you don't want to do it, why should a computer do it? I shaved off. If this and this were negative, I would have just shaved it off because there's no way the a negative number would have helped our total sum in any way. So I just went like, so this is where we're starting. Um, almost always, because I guarantee that -2 is not going to be helpful to us. So for array problems, we should shoot for linear time, which is O and N. That's our goal. Um, anyways, so um, mm, yeah, okay. Um, so I have recorded this before, writing the solution, but I don't use the screen recorder very much, and I lost the video, but it's saved in a WAR format that I couldn't edit, so I had to use another screen recorder. So I'm using this, but this is all written, and I have taken notes because as I said, the first time I did it, I thought it was it was recording, but it actually wasn't. Um, so I added notes as well just to help this go faster than the last one, the last recording. Okay, so this is the array, and then yeah, max sum of subarray. This is the solution. This is the function I wrote. This function finds largest sum of an array, and then we have two variables, which is highest sum, um, and current sum. So highest sum is set to math dot infinity, negative math dot infinity, which is like a Python thing where it allows you to have like negative 10 million, whatever it may be, because we don't actually have a highest sum. And I didn't put zero here. I didn't put zero here because negative numbers are not zero, so it would have messed with the accuracy of the result. So I think this is a good way to, like, if the array were completely negative and zero was like the best thing, we obviously don't have a zero, so it wouldn't be the highest sum. It would be like if we had -2 as a highest sum, then it would be -2. So that's why I did negative math infinity, and this is something you could do in a Python. I had to import math or something. Yeah. But obviously this is whiteboard, so. And the current sum is 0, which is because we don't have a current sum. Like, we are at this starting point, which is none, because it's we haven't started really. The moment we do, it's going to be this and then this. Yeah, anyways. And then this, we're going to transverse the list for I and R is transversing the list, and then we have current sum plus equal to I, and we're adding current sum to I because that will tell us what like -2 plus 1 would be, for example, as we iterate through and we try to get all the sums possible total. The highest sum equals max highest sum, comma current sum is now that we have now to find the actual highest sum for all the work that current sum did. Like, this number is finally going to, because it's in a loop and it goes in order, it's going to hit here first and then hit here. So this current sum is the actual current sum. And that's how we'll know what our current sum is, and then we're just going to do a simple max function, the built-in function of max in Python to get the actual highest sum, and then we're going to record it. And this is just to safeguard, like, if the current sum is negative, we set it to 0, which means it's an empty subarray. So negative numbers would still, it wouldn't impact. It wouldn't impact the accuracy of the result. To add some things that we should look for is if before we even do this loop, is if the arrays all have non-negative numbers, then the problem is, the entire subarray, if it was all positive, then the entire array would be whatever total array is, would be the total sum. And now we're just going to simply return the highest sum. Now, the other thing I think I already mentioned, but if we want to ask the clarifying question, if can the array, if it's all negative, can we just go, well, if it's permitted, are we allowed an empty array of a 0 instead of negative numbers? And what if the highest total sum was equal, because there could be multiple same total sums, and yeah, and this would reduce it to linear time, which is O and N, if we were to do it like that, because we don't. It's great because we only have to iterate through it once, and we immediately get rid of numbers that are not the highest because we don't care about that. And we already have prior knowledge of what came before, and we use that, which yeah, it's pretty cool. I was like, this is a pretty clever way to solve it. I think the solution I came up with at best was the quadratic time. I had used I used shortcuts like this, oh, this wasn't the highest and this isn't, and this isn't. Let me just start here. But that's, I think it was really hard. I already had the array in front of me, but we wouldn't, in real life, we wouldn't know. There could be a million entries, a million data points inside the array. So yeah, I think this is a better solution.